I was saying that, as you can see, integration by parts gets you to the final answer, but unfortunately, it takes a very long time, right? So there's so many steps in between. So the issue you have now is that if they do ask you to use integration by parts, they specifically ask you to use integration by parts, then you have no other choice but to go through all of this. But if you were left to choose your own method to solve the problem, I would suggest, right, as a second option, right? As a second option, try using U substitution. So initially,
Jonathan?
Yeah.
Are you aware that your screen disappeared for quite some time?
It did.
Yeah, we didn't see all that working out.
Okay.
We
didn't
thought
see
you
all
were aware.
Oh, right. So sorry. It must have been my mistake. I was hearing some noise in the background. So let's look back at let's start from the beginning, right? So we have a question. It's asking us to find the integral of sine x times cos x over 2 dx, right? And someone suggested to use the integral by parts and substitute u by sine of x and dv by cos of x over 2 dx. So that means our du will be cos x dx and v would be just 2 sine x over 2, right? So now using the formula for integration by parts, you have uv times minus the integral of v du, right? Which will be equal to u times v, which is just 2 sine x over 2 times sine x. Please mute yourselves, guys. If you're not asking a question, please. Thank you. So 2 sine x over 2 times sine x minus 2, right? Times the integral of sine x over 2 times cos x dx, right? So now what we said here at this point is we try to evaluate this integral now separately. So when we evaluate it separately, what we said was we need to stay consistent. So in the previous substitution, we substituted the dv for the function that had x over 2. So we'll keep, by staying consistent, we'll substitute our dv once again by sine x over 2 dx, right? And our u then will be the cos function, right? Meaning that our du will be, oh, sorry, this should not be there. Our du would be then negative sine x dx, and our v would be negative 2 cos x over 2. Right, so then using the formula again, we have now negative 2 cos times cos x over 2 minus 2 times the integral of cos x over 2 times sine x dx. And at this point here, you can notice that this expression that we get here is the same as the original function that we had. So now when we rewrite it all onto one line, originally we had to evaluate the integral of sine x times cos x dx, and we found this first part here, right? So that would be 2 sine x over 2 times sine x minus 2 times this integral, which we just found to be this entire thing here. So we just multiply the 2 by the entire expression that we found here. So that would be negative 2 times negative 2 cos x times cos x over 2, right? Minus 2 times the integral of sine x times cos x over 2 dx, which we said this part here is the same as that. So if you assume that that part is I, if you call it I, then you end up having I, the integral, original integral, is equal to 2 sine x times sine x over 2, right? Plus, right? Negative 2 times negative 2, that's plus 4 cos x, right? Times cos x over 2. Plus negative 2 times negative 2 once again, that's plus 4, the integral, the original integral that we had, which is I. So now we're solving for I. When you take the plus 4i on the left-hand side, you have negative 3i is equal to 2 sine x times sine x over 2 plus 4 cos x times cos x over 2. And you divide by negative 3 on all sides, and you get this expression as your answer. And you substitute back the value for I, and you have the integral now of sine x cos x over 2 dx is equal to negative 2 over 3 sine x over 2 minus 4 over 3 times cos x over 2 plus c. So what I said was, as you can see, integration by parts does get you to the final answer here. Before I move on, any questions at this point? And can you still see my screen?
Yes, we can see your screen. No
Right, thank you.
questions.
Thank you. So, please mute yourselves if you're not asking a question. All right, so as I was saying, you see that integration by parts does get you to the final answer, but it takes quite a few steps. So, and in a test or in an exam, if they really want you to use integration by parts to solve this, then you don't have any other choice but to go through everything that we just did, right? So, but if you were left to choose your own methods, I would suggest let's use U substitution, a method that we know from from last semester, and we are very familiar with it. So we can let our U be equal to x over 2, for example. That means our du will be 1 over 2 dx, right? When we substitute that into the expression, we have, therefore, sine of x, which will just be 2u, right? Multiplied by cos of u, and dx is just 2 du, right? And this is equal, therefore, to, if you simplify, 2 multiplied by the integral of sine 2u cos u du, right? And we know that sine 2u can be simplified further to be 2 sine u cos u, and this is all multiplied by cos u du, right? From our trigonometric identities. Taking out the 2, we have 4 now, times the integral of sine u times cos squared u du. So now here, we can use u substitution, rather v substitution in this case, because we've already used u, so let's use a v substitution. In that case, let our v be equal to cos u. In that case, our dv is equal to negative sine u du. And our integral therefore becomes 4 multiplied by v squared, and sine u du is just negative dv, so that would be times negative negative dv, right? Which just becomes negative 4 multiplied by the integral of v squared dv, which is negative 4 times v cubed over 3. And substituting back, we have -4 times cos cubed over 3, right? Cos cubed cos cubed u plus c. And we know that from our original substitution, u is just x over 2, so this becomes -4 cos cubed of x over 2 over 3, right, plus c, which can just be -4 over 3 times cos cubed of x over 2 plus c. And this should be our final answer. Now, look at the steps, the number of steps, and compare it to the previous integration that we used, using integration by parts. So you can see that there's significantly less number of steps there. You basically only had to rely on u substitution. You didn't have to use integration by parts, but you still got to an answer. And I would suggest, some of you might say, but well, the two answers don't look the same. If you expand this cos cubed here, right, you should get this same expression that we had before. So try that as your homework, and yeah, see what you get, right? So that's that. Yeah. Any questions? So what I want you to attempt, as we're running out of time, what I want you to attempt is try expanding this using trigonometric identities. And for example, you can use double angles and stuff. Try to expand this and see if you can get the same expression that we had here. Because we know the two expressions should be equivalent. We already sort of see that we have something similar because we have our 1/3 there, that's there, right? So we have the 1/3 that's there, and it's common there already, right? So we know we are definitely on the right track. We just need to see how we can expand this cos cubed of x over 2 to get this entire expression here. And obviously the constant of integration has to be there as well. Right, so I think that's it. That's the last question. Do you have any questions on this or any other question that we did?
The next session will still be integration by parts.
Right, just give me a minute.